So it's my privilege to invite our second industry expert speaker, Mr. Ashok Muthuswamy, Vice President, Total Quality Management at TAFE. And he's going to speak on agility in excellence, process, workflow, and asset management. And before joining TAFE, he's recently joined TAFE. He was with Tata Chemicals, where he was the AVP and plant head. Mr. Muthuswamy has 25 plus years of global experience in manufacturing, operation, Lean Six Sigma analytics, SCM, business excellence, and project management. In his journey, he has provided leadership to startup plants, establish plants, and revamp loss-making units into profitable entities through strategic intervention, putting effective systems. He's also published 2 books on design for Six Sigma and predictive analytics. Our GVC channel also carries his articles on the digitized work management. Over to you, Ashokji.
Hi, hello, thank you. Thanks for a very generous introduction. So with that, let me kick off my presentation. Just give me a second. Okay, so I hope my screen is visible, correct?
Yes, it is visible.
Brilliant. Okay. So I'm going to talk more about digital mindset. To a certain extent, yeah, it will also be. I will also be dabbling with technology. But more importantly, first is how do you have a digital mindset? And once you have that, how you can assemble various pieces of technology and integrate them into a whole. So that's going to be the crux of my presentation. So with that, and it's also going to be practical experience, very honestly. And I'm not going to dazzle you with some of the advanced technical developments in this field, but rather how I use technology to turn a loss-making plant into a profitable entity. So that's going to be the crux of it. Okay, so with that, let me set the context here. So first of all, like I said, thanks for the generous introduction. And as you introduced, you also mentioned that I'm from Tata Chemicals earlier. So at Tata, I was originally I was handling continuous improvement, business excellence, and process improvements, PMO, and all that stuff. And then I asked for a job change within Tata. I said I wanted to do a line function. And then I was put into a new plant, which was purchased from a private entrepreneur, which had its own standard. It didn't at that time reflect the standard of Tata's. It had its own standard. And I was just bang in the middle of that plant, starting from ground zero. It was a very, very uphill task. So, you find yourself in the middle of the ocean. So you either sink or swim, and my story is how I managed that. So that, but to be very honest, I was also given excellent freedom by my bosses. So I was able to take things from a very clean slate perspective and then build on things as we move on. So that's kind of the context which I want to set. And with that, I'm moving here. So I'm into the next slide. So my presentation is about a digital mindset. And if you see, to manage a plant, what do you want this? You want to operations management, process management, and asset management, right? So, and how do you do that in a digitalized fashion so that you can deliver world-class outcomes? So that has been my experience when I led the plant for the last 3 years. Took that plant from a particular level and left the plant at a very different level, much better level. So I'm going to share with you certain snippets of all these aspects which I dabbled, learned, stumbled here and there, but eventually delivered some very good outcome, which was ratified by some awards that we won, and also certain benchmarking studies that was done by the Tata Group. So I will go through that. So first of all, let me talk about digitalized operations management. So one of the tools that we use is daily work management. I was also told that this article which I put on LinkedIn has been shared with you. So there are some good information that anyone can leverage. So let me go through quickly about what is that we did on the daily work management. So I was at Tata Steel. They had one open house many years ago, and they had this brilliant system called daily work management, which is taking the pulse of the plant on various aspects like safety, health, compliance, dispatch, production, quality, efficiency. This is all the performance for the past week, and for the past day, and then what are the targets for the given day, and what are all the other availability in terms of material, personnel, and equipment. So you take a quick stock of situation. Tata Steel, they have a stand-up meeting at various different operations, and they go through these aspects. A quick review of past, a quick plan for the given day, and they typically do that roughly within like 15-20 minutes. So I thought that was a brilliant system, and I put that in place at our plant. Okay. So what is DWM? I'll just take a few seconds. It is a quick but focused tool to review and ensure quality and productivity. And certain key performances of the plant, such as safety, production volume, quality, dispatch, etc., are monitored. And deviations from the goals are identified and addressed. The focus is on rapid implementation of corrective and improvement action. And then, as I also mentioned, readiness for future production is also monitored and acted upon. And DWM cascades from one level to another. As a plant manager, I have DWM with my direct reports. And prior to that, they will have their own DWM with their team. So like that, it has to cascade from various levels. So, but one question, so what is digital here? So that question, I think some of you may be asking. So the last two slides, I was talking purely about operations management. What is digital here? So let me see how I can answer that. But before answering that, let me just go through a few dashboards of daily work management. See, like one of the things that any plant has to first monitor is your environmental performances on your emissions and effluent and all that stuff. So which we quickly monitor. As I'm putting all these various charts, and similarly, then various operating parameters. I'm only putting a couple of examples. What is your specific consumption, obviously, and a few other equipment health parameters. And then other parameters include what is your volume for the day, what is the quality for the day, what is your supplier quality, all that stuff. So this is the dashboard. So like that, I typically have around like 75 charts, and I monitor them. And I only ask questions if there are any deviations on these charts. If there are no deviations, the meeting will be over within like a few minutes. So that's how we typically do this daily work management. But again, what is the digitalization here? What you see is a good digitization, but is it digitalized? So I will answer that question. And I'm not going to discuss the distinction between digitization and digitalization. So I'm sure a lot of you will know, and those who need to know, you can please Google. So we digitized, but we didn't digitalize. So then, as like I also mentioned, how DWM happens. Individual department used to collect data in spreadsheets. These sheets were projected during daily meetings. Performances were discussed. Action items were developed and tracked. So all, as I said, very well digitalized. And it was not, I'm sorry, very well digitized, but not digitalized. And then came COVID. So by last February or March, we were all severely impacted by COVID. There were restrictions in terms of number of personnel who were allowed. Originally, only 33% of the people were allowed for the first couple of weeks, and then it went up to 50%. So those who collected all these data, collated them and put them up for daily meeting were unable to enter the plant because when I had only 50% of the people who can enter the plant, I only wanted those who are operating various pieces of equipment and other support functions. They are operated from their home. And our DWM kind of got disrupted. And this upheaval necessitated us to do something different. And this is where digitalization came into picture. So how did we digitalize DWM? So for example, Google Sheets were automatically enabled to acquire data from various sources like ERP and equipment, etc. And robotic process optimization, RPA, was also explored to fish data from various unlinked systems and capture them in one place. Sometimes it's always very difficult to integrate systems, but this is where tools like RPAs and bots come very handy. You don't need to have an integrated system. You can have various different systems. Just like how a human being goes from various repositories of data, copy paste, the RPA or bots exactly do the same thing. They mimic the human activity in collecting data. So these development eliminated the human intervention that required to collect data for daily meetings. And this is where we digitalize the data. And our physical meetings were switched to virtual modes, and we were able to get the pulse of the plant within same like 20 minutes. And stakeholders could attend the meeting from anywhere just with a smartphone. And the time of the personal freedom, usually like people would take like 20 to 30 minutes to collect the data. Now all that with RPA is gone, so people can spend more time on value adding activity. And this is where we digitalized the data view. And I'll tell you, the idea for this came from an external competition for which I was a jury. And I never shy away from any external engagements. If CAA asks me to be a jury for a day, I do that because I get around like 20, 25 good presentations from various companies. And one very small company in tier 2 town said that they use bots to do their invoices. Like they have a lot of information on various files sitting on their hard drives, and they use bots to assemble an invoice. And that was like abracadabra moment for me. So if they could do it, why not us? So that's how, with spending some very, very insignificant amount, this was kind of made possible. And as I said, the RPA, robotic process automation. I don't want to go deep into it. I'm not an expert, but I'm a user. So it is what it is it's an AI-powered digital tutor that does the repetitive task, manual task like extracting data and all that stuff, and frees up people. So this is one aspect of where we digitalized our operations management and our reviews. And moving on, I will also discuss about digitalized process management. So these are the three aspects I want to discuss: digitalized operations management, which I just discussed. The next, as I said, is digitalized process management, and followed by digitalized asset management, so that we deliver world-class outcome. So now I will talk about this digitalized process management. So see, like specialty chemicals business requires adherence to stringent quality specifications. And oftentimes there are certain experts who know the influence of process parameters on product specifications. Usually certain experts, not all of them, but some of them do not share that information very freely. I'm sure we all would have come across. But good number of them do share. But still, it's an opinion, or it's based on a gut feel. You change this knob, you change this lever, you increase this flow, you decrease this temperature, and you get this outcome. It's all based on many, many years, 30, 35, 40 years of the experience of individuals. And mostly it may be right, but sometimes it may not also be right. And it was purely an art. So we were wondering, what is the connection between your product specification and your process parameter? Typically, as an engineer and also as a data enthusiast, I would always think everything is a function. Y is a function of X. Sometimes the function can be linear, sometimes the function can be a cluster, can be a non-linear, whatever. But what is the connection between the outcome that you want to deliver versus the enablers that you have? If you could crack that, then you can free up your process from the clutches of all these uncertainties. So our focus was to understand the science behind this art. So what we did based on past data, we put several predictive analytics model which we built. And we were able to establish connections between process parameter and product specifications. So we use certain tools like neural networks, clustering, and good old-fashioned regression a good number of times. We developed several calculators, so that gives the process setting for a record product specification. So, for example, if you want a product with a particular specification, you just go put it in your calculator, what specification that you want, and then the tool will tell you that what are all the process specifications that you need to have, like, whether it's in terms of, as I said earlier, whether it's in terms of temperature, pressure, RPM, and various other aspects, like in terms of volume, how much you dose of which acid at what time. All these things we were able to unlock that secret of process, and this gave us a good grip on our process, and we were able to repeatedly uh, deliver the right product specifications. And no cost was involved for these analytics, as these were developed in-house. So we had few Six Sigma black belts who knew a good deal about regression. Then we also had a data scientist in our corporate function. So we also tap the help of that person to do some neural network and clustering. So all these things, as I said, we didn't spend a penny for this particular thing. So we developed all these analytics in-house, and then only we upgraded our instrumentation using advanced SCADA and PLC. And then we also spent some good money on, once we understood the pulse of the process, then we went for more process improvement. I think in the previous presentation also kind of touched upon these aspects. First, you get a grip of certain hygiene factors and then go for optimization. That's kind of the approach that we took. So we also put in place several PID loops. Those who are a lot of instrumentation engineers here hearing this, or chemical engineers know this PID loops. We put that several PID loops, which is a closed feedback based system, which can alter the process parameter based on the dynamics of your operations. Similarly, we also put digital QKs using instrumentation test systems and all to ensure quality and productivity. And similarly, digital SOPs were also put in place using novel approach based on external benchmarking. Here's also one very funny, interesting story. As the team which presented before me, they mentioned about Tata Steel. And Tata Steel is a very, very large entity. Jamshedpur alone produces 8 to 9 million tons of steel a year, and in terms of revenue, they may be around 50-60,000 crores. Very large plant, and they have all the resources in the world to go do digitalization of the plant. And when I was at Jamshedpur, I was dazzled by the digital SOP, where they had an animation. They have a TV in each of the steel shops, and animations running about how to change a bearing, how to replace a motor, and all that stuff. And they had the muscle and willingness to put all those things in place, and obviously they have the resources. We also had the willingness to do that, but we didn't have the resources. So what we did is we found one very clever way. All that I did is I asked our folks to do some YouTube video of various aspects of running the process or doing the maintenance. And we hosted that YouTube video within our own company's Google account, which is encrypted and it can't be accessed from outside. And all that we did is we put a bunch of QR codes in the shop floor for various things. If you want to know this, people just have to take a tab and scan it, and the digital SOP will be there in no time. So like that, we put in place certain smart things without necessarily spending a whole lot of money. So whenever I do the benchmarking, I always find out why somebody has been doing that and what outcome it gave us. And how to do it is up to us. Sometimes we may not necessarily have the resources of certain organizations. So then what do you do about it? So the house is something that we designed ourselves, whereas what and why that we took it from outside world. And as I said, then once we refurbished our SCADA, and also once we also got the process pulse. We took the art completely out and we made it all like very mundane. We de-skilled this whole thing. So one just needs to enter the product specification in the SCADA, and the process will automatically be calculated based on the algorithms that we developed in-house. So that's how we digitalized our processes. And again, like I would like to tell you, understanding the processes preceded the automation or digitalization, because you can digitalize a process which you don't understand a whole lot, and the outcome that it will give you will be garbage in, garbage out. So before you digitalize, use all these 4.0 and all these things, understand the processes, have a good pulse of it, and then use these digitalization for even taking it to the next step. At least that is the philosophy I follow. So which worked served me very well. And similarly, like a few other things which we did in another plant, like boiler analytics. So there are like 30 plus parameters. I'm just showing you a select section of what all influences boiler efficiency. We just did one simple regression and we found that a couple of parameters were key to boiler efficiency. We tweaked that and we increased the efficiency of the boiler from a particular level to another level, which gave just 60 lakhs just only by changing the setting in the equipment. Nothing much, 60 lakhs a year, just by tweaking certain knobs in the boiler DCS. And then that was later on followed up with the digitalization, where an online analytics system was commissioned to continuously monitor various parameters, identify patterns, locate issues, causes, and put in place corrective actions. So again, here also the story is first you optimize based on what resources, or without any resources you optimize, you understand various aspects, and then go for digitalization, because at that time when you're speaking to a vendor who is going to do the digitalization, you will be fully conversant at least with the technical aspects. You may not know the digitalization aspects, but you will know your own process aspects and engineering aspects of whatever you're trying to accomplish. Finally, moving on to digitalized asset management, which also the team before me, they also presented. So here, the first thing, like I said, we always look for is how you can achieve without spending a penny. So here, what we did, we had a lot of raw data in our maintenance logs, and people are still using manual logs. So first thing we did is we made it all Google Sheets, and we removed all the manual logs so that people can tap using their phone or quickly go to a console, laptop, tab, whatever input devices. They just log in the various maintenance issues of the day. And what happens over a period of time, over 6 months, you'll be amazed at the number of rows that you generate. And then you can use something like natural language processing, NLP, to identify chronic issues. Where are the chronic issues? And which one do you need to attack? So, so that way, you don't necessarily need to have everyone doing Pareto and taking the manual data, converting into a numeric data, doing Pareto, all that stuff. You kind of again de-skill this whole thing. You just let people write whatever they want and let the machine do this Pareto. So use the artificial intelligence, machine learning, all that stuff to mimic what people do, and so that the maintenance guy, he can go and work on another machine without spending a whole lot of time on data analytics. So that's the way that we approached here. Again, like I said, this also we did it just with our own internal data scientists. Doesn't take a whole lot of effort. With some smart tools, you can, I mean, anyone can do this. I'm sure ABG is a very large group and you will be aware of all these things. But I'm just telling you my story of how I accomplished and maybe it's giving you a spark about what you can do. That finally, then digital monitoring of assets. Here also, my colleagues, I mean, a couple of folks before me, they gave a nice presentation. So what we also do is digital monitoring of assets of all these rotating equipment, bearings, gearboxes, motors, pumps, blowers, fans. We used to do intermittent conditional monitoring of these assets to identify one part, overheating, loss of lubricant, all these things. And then what we also found is we took certain critical assets in a chemical plant. There are like 5, 6 critical assets in a plant. I mean, depending on the size. And those critical assets, we just put real-time condition monitoring stuff, and also we also put some cheap sensors, but it's a very integrated sensor which will take into account the 3-axial vibrations, acoustics, and noise, and various other, I mean, temperature, and also all the electric power parameters that came from DCS. So like that, we were able to assemble, I mean, put these sensors, put them on Wi-Fi, and without spending a lot of effort on system integration, we were quickly able to connect them to SCADA and get equipment health feedback. And then one more thing, leveraging some statutory systems. See, for example, we are mandated by the Pollution Control Board to put the stack monitoring system or effluent parameter monitoring system. These are all like statutory requirements by the Central Pollution Control Board as well as State Pollution Control Board. And these systems send the stack emission and effluent quality parameters online on real-time basis to the pollution control boards. So this is great, it's a statutory thing. But then these assets, we also use them as proxy measures. So all our emission, we used it, I mean, while we commissioned it for the pollution control board purposes, statutory requirement, we also utilized those assets to as a proxy measure to tell us our process health. For example, monitoring the SOx, NOx will tell you how good your combustion is. Monitoring the SPM will tell you whether you are losing any fuel or product in the air. Similarly, for example, monitoring the effluent. The effluent pH will tell you that, for example, if the pH is too low, it will tell you that you are using too much acid, so you are losing some valuable commodity. If the pH is too high, you also know that your product quality will suffer. And similarly, if there are a lot of solids in your effluent, you know that your filtration systems are not good. So in other words, whatever assets that were there, we also leveraged them to as a proxy measure and did some correlation so that we were able to connect them to our processes. So these also, at least I personally consider as digitalization with no extra cost. And once you integrate all these to your dashboard, you get a very nice digitalized dashboard based very much on your existing assets without putting too much, without spending a whole lot of money. So then one more thing, like what doesn't go away, right? So no matter, industry 4.0, digital twin, all these fancy things are out there, but never lose track of continuous improvement. So whether it's TQM, Six Sigma, TPM, all these stuff, you use them and first you optimize your processes and then digitalize, because you don't want to digitalize a process which is not optimized. Before you are going for digitalization, you need to make sure all your special causes are eliminated and your system should only be with common cause. so that you get the best bang for digitalization. Or else you will have a digitalization system in your establishment, but anyway you will continue to have failure if you are not optimizing. So the result, so in over a period of 3 years, what we did is we achieved digitalization cost effectively without much capex. Of course, some money was spent on certain areas, but that was after optimizing the initial stages. And the impact was measurable in terms of, there are only 4 things on this: fixed cost, variable cost, on time in full, and quality. So the impact was measurable on all these 4 parameters, which are very dear to me. I always look at these four factors, and if you get these 4, then all the other factors are all derived from this. Whether it's the contribution, EBITDA, or your top line growth, bottom line growth. Everything is a function of. They are all dependent on these 4 parameters. So we found some significant impact on all these 4 parameters. And our efforts also won certain awards in CA's digital competition. And also, these initiatives were identified as best practices for horizontal deployment in much larger plants. So these are some of the results that we achieved on a limited scale. And so now what next? So now the plant is ready for the next stage, such as digital twin and other digital advancements. So now only, I think it will be, the time will be right. So instead of doing all these things much earlier. So we set the plant at this stage. So with that, I would like to thank you all and take any questions.
Thank you.